guys, this does not look like a fun one. This person has student loans of $590,506.36. And it says here they just made their first payment of $50. They're tackling it brick by brick. And then another person commented, you covered 32 seconds of interest. I don't think this is right. There's no way this loan is growing by $50 every 32 seconds, but I do kind of want to know how fast is it growing. Let's find out. I think we got to look at a worst case scenario and a best case scenario. It says here this is made up of 31 loans where the interest rates range from 3.4% to 9.08%. In the worst case scenario, the majority of the money is going to be the 9.08% loans. And in the best case scenario, the majority of the money is going to be in the 3.40% loans. And then to make this even worse, let's compound continuously. And then for the best case scenario, let's compound annually. So now we can do the math, the Andy math. So the formula for continuously compounded interest is A equals PE to the RT, where P is your current amount, R is your interest rate, T is your time in years, and A is your amount after T years. So now let's plug in our values. For the interest rate, it's going to be 9.08%, or in other words, 0.0908. And then for the principal, the amount we owe right now, let's put the entire loan at this interest rate. That'll make it the worst case scenario. And then for the T, we don't know the T. We're trying to solve for T because we're trying to figure out how long it's going to take to grow $50. So we need to make this amount $50 more than this amount. So it'll be $590,556.36. So we're trying to figure out how much time does it take for this amount to grow into this amount, which is $50 more than this amount. Our ultimate goal is to solve for this variable T. First, we can divide both sides by this amount. On the left-hand side, we're going to have this fraction. All of this divided by all of this. Since the top and bottom are both even, this can definitely simplify, but nobody's got time for that. We can just leave it like this. And then on the right-hand side, this and this are going to cancel each other out, leaving us with e to the 0.0908t. So now since this t is in the exponent, we want to take the logarithm of both sides. You're going to use a logarithm anytime you have the variable in the exponent. And this is the reason why. Anytime you take a logarithm of something, you can take that exponent and bring it to the front. Here's the notes right here. So we can take this exponent and bring it to the front. And now the t is no longer in an exponent. And then using these notes, we know the natural log of e is equal to 1. So we can change this natural log into a 1, which means it's going to disappear. And then from here, to solve for the t, we can divide both sides by 0.0908. On the right-hand side, this is all going to cancel out, leaving us with t. And on the left-hand side, we have this natural log of this fraction divided by this. We basically got to plug this into a calculator. So after we do that, we get t is approximately equal to all of this, and that's going to be in years. I have no idea how much time this is. Let's play around with it a little bit. There are 365 days in 1 year. So if we multiply this by 365, we'll have the number of days. And that gives us about 0.34 days. I have a much better idea of this. This is going to be about 8 hours. But we can get a more precise estimate. There are 24 hours in 1 day. So if we multiply this by 24, we're going to know the number of hours. It's about 8.17 hours. And then from here, we can do all of this math, and we end up with about 8 hours, 10 minutes, and 6.8 seconds. In this worst case scenario, the loan is going to increase by $50 in this much time. And if he doesn't start making some large payments soon, this time is going to keep getting shorter and shorter. But at the very beginning, it's going to take 8 hours, 10 minutes, and 6.8 seconds to grow $50. In order to pay the interest only, it's going to be about $150 a day. That's not even going to pay down the loan. That's just going to pay off the interest. To pay off the loan, he's going to have to do even more than $150 a day. So hopefully the best case scenario is a lot better. Here's the formula if you're going to compound annually. We still have the principal, the rate, the time, and the amount after t years. Let's plug everything in. In the place of the rate, we can plug in 0.034. That's 3.40%. In the place of the principal, let's plug in everything. And then in the place of the amount, we can plug in $50 more than the principal. So we're trying to find out the amount of time it'll take this to grow $50. For the first step, we can divide both sides by this. On the left-hand side, we're going to have this fraction. And on the right-hand side, these are going to cancel each other out. And then from here, the variable is still in the exponent, so we're going to take the log of both sides. And then with the logarithm, we can bring this exponent in front. And now the natural log of 1.034, this is not equal to 1. It's going to be some number. So let's divide by that number, whatever number the natural log 1.034 is. On the right-hand side, these are going to cancel each other out, so we'll be left with t. And then we can plug all of this in a calculator to get approximately 0.0025 years. This already looks much better than this one. Let's see what it is. After we do all the same math, it gives us 22 hours, 11 minutes, and 1.1 seconds. And that is the best case scenario. This person is going to have to pay about $50 every day just to cover the interest. I kind of hope this person got a really good job or that this is fiction. How not exciting.